Hi again, Station 3, Applications of Exponents and Logs, B and C. Back to my lined paper. So for B, new parents are looking to start a fund for their newborn baby. They have $5,000 to invest in an account, so that sounds like some important information. So $5,000 to invest. They want to know the percentage rate. So what percent is necessary for there to be $25,000 in the account by the time the child turns 18 years old. So 18 years later, we want $25,000. So there's a couple of different ways you can do this problem. I'm going to do both ways. The first way is the way that I had on the answer key during class, and that's using your point ratio form. So point ratio form requires you to have 2 points. So the first point would be your initial investment. When you initially invest, our point ratio, when you initially invest, no years have passed and the parents are investing $5,000. Then 18 years later, they want a payout of $25,000. So I'll have my one pair will be X and Y, the other pair will be X1 and Y1. It doesn't matter which is which, so if this is my X1 and my Y1, this is X and Y. I'll put it into the point ratio form, which is Y equals Y1 times B to the X minus X1 power. Okay, so when I put that into that equation, I will have Y is 25,000 equals 5,000 times B. Now B is what I'm looking for. X is 18 and X1 is 0. So I start to solve this by dividing both sides by 5,000. 25,000 divided by 5,000 is 5 equals B, and 18 minus 0 is just 18. So I get 5 equals B to the 18th power. I'm just going to rewrite that over here so you can see a little bit better. 5 equals B to the 18th power. So remember, in order to solve anything with an exponent of a number, we just raise it to the power of its reciprocal. So I raise it to the power of 1 over 18. I have to do that to both sides. These exponents will cancel out to a 1, which I don't need to write, and 5 to the 18th power, to the 1 over 18th power is 1.094. All I'm really concerned with in this part is the amount that's away from 1. In this case, it's bigger than 1 by 0.094, which means that that is 9.4% interest rate. So the interest rate is 9.4%. So that's the first way. The second way you may like also. It's very, very similar. And well, let me just show it to you. So the second way is using the equation that we have for when we're given the percentage rate. So we can use the equation Y equals our starting amount times 1 plus, and it's plus because we're increasing the interest rate to the X power. So now we know all this information except for the R, because that's what we're looking for. So the initial amount we're investing, which is our A, is our 5,000. 18 years later is going to be our X, and the 25,000 is our Y, because that's our payout. So when I fill in all of the numbers here, I get 25,000 equals 5,000 times 1 plus R, that's what I don't know, to the 18th power. So this looks very similar to the first way. And again, I start by dividing out my 5,000, which gives me 5 equals 1 plus R to the 18th power. Again, I'm going to need to raise this to the 1 over 18 power so that I can cancel out my exponents. And I'm going to put this up here. So 5 to the 1 over 18 power, I did that before, is 1.094, and that equals 1 plus r. Well, how do I solve for r? I subtract 1, which leaves me with my 0.094 equals r. And because we need to change this to a percent, move my decimal place 2 spots, and I get my 9.4%, which is what I found using the first way. So either way, point ratio form, finding your 2 points and using them that way, or using our equation for interest or exponential growth. In the next problem, we're using the same equation for exponential decay. Okay, so either way. So on to problem C. Problem C says a Cadillac Escalade has a depreciation rate of 27%. So depreciation of 27%. If the initial value of the car is $70,000, it's a pretty expensive car. Initial value, $70,000. When will the value of the car be $15,000? So when will car equal $15,000? So the fact that they're asking when, they want to know time. So that's what we're looking for. So we write out the equation, y equals our starting amount, 1. In this case, depreciation means I'm decreasing. So minus the 27% in decimal form, 0.27, to the x power. Or, okay, so I got a step ahead of myself. Instead of putting in the 0.27, 1 minus our rate. Okay, last problem we added because we were increasing, now I'm subtracting. Okay, so now let me actually go in and plug in the numbers. So y is going to be what the car will equal after the amount of time. A is our starting value. R is our percent, but we want to turn it into a decimal, so that's going to be 0.27. That's going to be our R. And X, that's our time. That's what we're looking for. So that's going to be our unknown. So plugging in everything we know, 15,000 equals 70,000 times 1 minus 0.27 to the x power. So starting out the same way, dividing by 70,000 gives me 0.2143. And like I said, the more decimal places you can keep, the more accurate your answers will be. So now I'm going to calculate 1 minus 0.27, that is 0.73 to the x power. So I can't calculate this the way it looks right now without guess and check, and we've moved beyond that because we have the property, the definition of logs. So I can change this to the log form. So this is my A, this is B, this is X. So I change this to equal the log base B, 0.73, of A, 0.2143, and when I calculate that, I will find out what X is. And after putting that in a calculator, which we will have to use change of base property, so change of base property, remember, says that I take the log of A, so log of 0.2143, and divide it by log 0.73. I will find out that X is equal to, I'm kind of going backwards here, X equals 4.9 years. So what amount of time? Time is 4.9 years. Obviously, when you're taking these notes, you don't have to go up and around and all about. Hopefully you have enough room to do all of that on that page. Okay, so 4.9 years. It doesn't ask us to change that into months, so I can just leave it as the decimal. Don't round it up to 5 because it's not exactly 5. So get to a good 10th or 100th of a year when you're answering a question like that. Okay, so there's the conclusion of Station 3. Look for the screencasts for the homework.